Hello, everyone. Welcome to physics class. This class today will be the continuation of our previous topic. On the last class in physics, we discussed fundamental quantities, and today we're going to have the continuation of that topic. In the last class, we discussed about fundamental quantities. We said they are quantities that are independent. We also discussed fundamental units. We said they are units that are independent. We also discussed about derived quantities, which are quantities that depend on other quantities. Derived quantities are quantities that depend on other quantity. We discussed about derived units also, and we said that derived units are units that depends on other units. So we also went ahead to do some derivations of some derived quantities in our previous class. And today we are going to continue on this topic by considering another subtopic under fundamental quantity. Do not forget, we've discussed in our previous class, we've discussed fundamental quantity, fundamental units, derived quantity. And we're also able to do some derivation in our previous class. So in case you are not chance of joining the class, last class, do well to visit the YouTube channel and have a detailed video about the previous class. Okay, all right, today we are going to continue with the same topic, which is fundamental quantities. Fundamental quantities. So we want to consider the continuation of the topic today, fundamental quantity. I believe everyone can hear me properly, and also I believe you can see the board. Before we dive into the topic proper, let me be sure that we are all on the same page. You can hear me, you can see the screen where I'm writing on. Kindly signify by dropping a message yes or just an emoji so we can start properly. We want every one of us to follow. So we want to be sure that you are following and you can see the screen and also you can hear me properly. Just drop a message in the chat box that yes, I can hear you. Yes, I can see what you have on the screen. We're about to start today's topic. I'm waiting. If I can just have one or two reaction on what I've just said. You can hear me. You can also see the board. You can see what I'm writing on the board. Please kindly signify so we can kickstart. Waiting. I'm still waiting. You can hear me. You can also see the board. Please just thumbs up or say yes so we can proceed. All right, so we have a response. So let's proceed to today's topic. We are working on a subtopic, dimension, still under fundamental quantity, dimension. All right, I'm going to give us the definition of what dimension is. Dimension all right. Okay, so we are considering dimension still under the topic still under the topic fundamental quantities. And we have here the definition of what dimension is. So let's consider the definition together. Dimension. Dimensions are measurable properties used to describe the physical state of a body or a system. Dimensions are measurable properties. Let's underline the key points. We are trying to break down the definition. Measurable property used to describe a physical state of a body or a system. Now we are talking about dimension under fundamental quantities, and the definition says that it is the measurable property used to describe a physical state. And we all know that we have the state of matters. We have state of matter, which is the solid, the liquid, and the gaseous. Now, the measurable properties used in describing this state of matters are said to be dimension. The measurable properties used in describing this state of matters, this physical state of matter, is said to be dimension. So under the topic we are considering today, we have three dimensions we are going to be talking about. Three fundamental dimensions we have to describe physical quantities. You know, we have, when we talk about quantity, we are talking about the state, or the, let me say, the body or the system we are describing can be quantifiable. That is, it has a quantity. Now, if I'm talking about, let me say, a shape of this way, this is a rectangle. Of course, I can quantify this by knowing the length and the breadth. So, physical quantities that can be described by some measurable properties are said to be fundamental quantities, which we discussed in the last class. And today we want to look at the three fundamental dimensions we have. Dimensions that can be used to describe these quantities. Dimensions that can be used to describe the physical quantities we have. We want to consider those dimensions. And we have just three of them. They are basic, three fundamental dimensions. The first one is length, which is represented by letter L. And we have the second one, which is mass, represented by letter M. And also we have time, represented by letter T. So in UTME question, you can be asked that we have dash fundamental dimensions in physics. So we have just three: length, mass, time. So you can abbreviate it as LMT. So we have three of them: length, mass, and time. Length, mass, and time. So we are going to be using these three dimensions to describe some quantities. Last class, we discussed about some derived quantities. We also discussed about some fundamental quantities, right? So we want to relate those quantities to these three basic dimensions that we have. We want to relate it to them. Don't forget that last class, when we were discussing, we said that the derived quantities are 7 in number. No, sorry, the fundamental quantities are 7 in number, while the derived quantities are unlimited. We have more depending on discovering. But the fundamental quantities are 7 and the derived quantities are more. We have so many derived quantities. So today we want to see how we can do some derivations for the dimension of some quantities. The derivations for the dimension of some quantities. And this is a part that UTME always asks questions on. They ask questions on what is the dimension of power. So we are expected to do a derivative to get the dimension of power. And all you are going to be making use of is these three dimensions: length, mass, and time. Take note, each of them have an alphabet. Length is L, mass is M, and time is T. All right, so I believe you are with me. So we can proceed to the next application we have in this topic. If you are with me, please kindly signify before I proceed to the next one, or before I rub off the board. I want to be sure that we're on the same page. All right, good. So we are going to take some applications, which are UTME applications, on how to answer questions on dimension. All right. So I'm going to rub off the board. So we have the first application, app 1. Okay. So we asked this question: what is the dimension? What is the dimension of power? What is the dimension of power? This is UTME question 2002. So we are asked, what is the dimension of power? So what we expected to do in this question is to derive it. We have to derive the dimension of power, which we are going to do together. Okay, so we are not giving option here. We want to solve to know the correct response. What is the dimension of power? Solution. You first have to express the formula for power. Of course, power equals to work over time. Power equals to work over time, right? So now we need to start relating those formulas together. Work equals to power equals to work over time. We can also say that our work is equals to force multiplied by distance. Some textbooks will say displacement. So let me use displacement, which is also representing the distance. So we have work also is equals to force times displacement, which is force times distance covered. So now P will be referred to as force. Now I'm changing the value of work to force times displacement, force multiplied by displacement, all right? Then over time. Now with this, again, we still need to simplify by saying power equals to force times. Let me use displacement over time as a separate fraction. Displacement over time. Power equals to force times. Now, if you can recap that displacement over time is also equal to velocity. All right. Okay, to make this very easy, let me quickly share us a picture in our chat box so we can view from it those formula. Okay, let's have the picture so that will be more easier for us to check the formula. All right. So if you check in your chat box, I've sent a picture that comprises of the formula we have been using so far. Okay, so we can proceed now. Let's proceed. We said displacement over time is also velocity. Velocity. You can check the picture. You will see the formula there. Velocity. Now, force is what? From the picture I sent you, if you check, you will see that force is mass times acceleration. Acceleration. Let me write it in short form. Acceleration multiplied by velocity. So power equals to mass times acceleration times velocity. So let's go ahead to simplify. Mass will still remain as mass, but acceleration is also velocity over time. Acceleration is also velocity over time. Acceleration is also velocity over time. So we have velocity over time multiplied by, what is velocity? Velocity is displacement over time, right? Velocity is displacement over time. So we have displacement over time, displacement over time, and we'll proceed. Power now equals to mass multiplied by, we still have another velocity here which we need to simplify, and that also will give us displacement over time. So we have displacement over time, all right, then over time again times displacement over time. Power equals to, now let's simplify it. We have mass, of course, mass multiply by, now what we have here, this displacement over time, this time will come to the denominator. Okay, so we're going to be having displacement, okay, multiply by the second displacement we have here, displacement, okay, then over, initially we had time, just 2 of it at the denominator. So we have time multiplied by time times, now this time that we have here, this one that we have here, this particular one, we come to the denominator also. We also come to the denominator. So we are going to have another times time again. Is that taken? So we have now P, which is power, equals to mass. Mass is talking about what alphabet? We said mass in the dimension is M. So this is M times. Displacement is talking about length. Displacement is talking about what? Length. So that is L times another displacement again, L, over time is represented by T times another time, T times another time, T. So we have power equals to M L square over T raised to power 3, which will be equivalent to ml square. Okay, the law of indices states that 1 over a raised to power 3 should be equals to a raised to power minus 3. So the same thing will affect this t raised to power 3. We are going to have t raised to power minus 3. So the dimension of power is ml square t minus 3. Okay, the dimension is ml square t minus 3. I believe that is clear to us, right? If this explanation is clear to us, please thumbs up so I will move to the next application. All right, great, okay. Can I have one more emoji? If this application is clear to us, good. Okay, very good. So we'll move to the next one. But before that, let me chip in that sometime you'll be given a question and you'll be asked to find a value of X, Y, and Z. Okay, so because those questions also come in UTME, let's say I have M, X, L, Y, C, Z. Okay, so we are asked to find the value of X, Y, Z, okay, for the dimension of power. Take note. Find the value of X, Y, Z for the dimension of what? Power. And we've solved for power. This is the dimension of power. This is the dimension of power, okay? So if you have to find the value of X, Y, Z, what we are asked to do is to write the value, that is the exponents, the power of each alphabet. So for here, we have 1, invisible 1, which means X equals to 1, Y equals to 2. This is going to be Y, this is going to be Z, and this will be S. So we have Y equals to 2, then Z will equals to minus 3. So this is another form of question that the UTME do ask concerning the topic dimension of quantities. All right, so let's move on to the next app. We are taking just 2 apps and we'll be having evaluation with the remaining one. Okay, so let's take up 2. We want to derive another dimension. I believe I can rub off the board. Okay, so up to we're asked to, okay, what is derive the dimension of pressure? Derive the dimension of pressure. And that will be UTME question 1995. So we are asked to derive the dimension of what? Pressure. Solution. From the same picture I sent to you, if you check carefully, you will see that pressure equals to force over area. Pressure equals to force over area. So we have to start simplifying each of the formula. Of course, force will be equals to mass times acceleration, and area will be equals to length times breadth. But in this case, we are working with length alone. So we say length times length, length times length. Okay. So pressure will be equals to mass times acceleration over length times length. Okay, so we proceed to simplify again what acceleration is. Acceleration is pressure now will now be equals to mass times acceleration is velocity over time. Velocity over time. So we have velocity over time. All is divided by length times length. All right. So I believe we are on the same page. Okay. So pressure will now be equals to, we have to still simplify velocity. It's always good that you have all those formula in your mind because you'll be using them often. Velocity, we need to simplify that. Mass multiplied by velocity has its own formula also, which is displacement over time. Displacement over time. So we have displacement over time Do not forget we have initially we have time there before. So that means the denominator will be having 2 time, that's time multiplied by time. Displacement over time. Then the initial time we have there will still be there. Okay. So now everything should be over length times length. Okay. Pressure equals to, now let's simplify this. You see the time we have here, time times time is time squared, that's t squared. So we can simplify it that way and say that mass is m, okay, multiplied by the displacement is talking about length, okay. So that will be L over time is talking about letter T, that's T multiplied by T, okay. Let me have a bracket like this, divided by another bracket, L times L. So the line of division that I have here, I've changed it to division sign here, okay? L times L. So we have M L over T square, okay? Because here the denominator is 1. So we have divided by L square, because L times L will be L square, okay? So we have ML over T square. Now this cannot be simplified except we change the division sign to multiplication sign. So we have times. Now, if you can refer back to our mathematics class, while we are talking about simplification of fraction, we talked about reciprocation. That's reciprocal. So if I have L squared over 1, the reciprocal is 1 over L squared. So once we change to multiplication, we'll be having 1 over L squared. That's the reciprocal, okay? So multiplying now, we have ML times 1 is ML over C squared, then L squared, okay? So we can divide, L cancel 1 out of the L, we have 1 left. So we have M over T squared L. And finally, our pressure will be equals to M T, okay, T minus 2 minus 1, okay? So that is MT squared N minus 1. But it is always advisable to arrange in alphabetical order. For the sake of objective, you might not see this in your responses. So let's arrange this alphabetical order. ML minus 1, T minus 2. So we have ML raised to the power of minus 1, then T raised to the power minus 2. So this is the dimension of pressure. This is the dimension of pressure. So if I'm going to ask that what is the value of X, Y, Z for pressure, okay? If you are with me, I want your response in the chat box. I believe this up to is clear to us. If you are with me, please, the up to is clear to us. The simplification is clear to us. Good. Okay. So I want to ask a question now that let's say I'm asking for the value of X, Y, Z. So I have this. Let's use a green ink now. We have M, X, L, Y, then C, Z. So referring back to this that we got, that of pressure, okay? So I'm asking for the value of X. What's the value of X? I need your response in the chat box. What's the value of X? Referring to this. So you just need to compare both sides and get what X is, what Y is, and what Z is. So in the chat box, what will be the value of X? If I'm having mx, m raised to the power of x, l raised to the power of y, and t raised to the power of z. Good, awesome. Great response, Faith. That's a great response. Okay, what about y? What will be the value of y? Waiting. What will be the value of y? Still waiting. The value of y. Just need to compare both sides, okay? Just need to compare. This is y and this is y. So what will be the value of y? Minus 1. Great response, Faith. All right. So let's go for z now. What will be the value of z? The value of z? Minus 2. Awesome. Awesome. That's awesome. Okay. So these are the way they can ask question in UTME. You can be asked to get the value of x, y, z in your UTME question after you have solved for the dimension of a particular quantity. Is that taken? Okay. So I believe the second application is clear to everyone. So we are going to move to the next thing now. We're going to move on to the next thing. Permit me to clean the board so we can move on to the next thing. Okay. So now I want to share with us a table that comprises of mostly asked, the quantities that are mostly asked in UTME. Yes, the dimension for the quantities that are mostly asked in UTME. So you can have it also with you, then go through it. You can learn it, have it in your mind. So, okay, I believe you can see what we have on the screen here. All right, so this is a summary table for most of the quantities that will be asked in UTME and their dimension, okay? Their dimension. So we have, starting from area, we have volume, we have mass density, frequency, we have velocity, speed. Or you can see that velocity and speed, we just have one dimension. That is, velocity and speed have the same dimension. Velocity and speed have the same dimension. Okay, we have acceleration, we have force, we have impulse, work and energy also have the same dimension. Okay, we have power, which we have solved recently, momentum, pressure and stress also has the same dimension. So with these charts, you can be asked some question that which of the following has the same dimension with pressure? Okay, that's a CBT question in UTME. Which of the following has the same dimension with pressure? And you have options given to you, and stress will be included. Stress will be included in your option. And your correct answer will be what? Stress, because stress has the same dimension with pressure. So take note of some of the quantities that have the same dimension. We have stress and pressure, they have the same dimension. Work and energy has the same dimension. Velocity and speed also has the same dimension. Okay, has the same dimension. So you have to know this table in your mind, because most of the time you might not need to solve. You have to be smart while answering question in UTME. So if peradventure you know the value, you know the dimension of area, and you are asked to find the value of x, y, z, you know that x will be 0, y will be 2, and z will be what? 0. Is that taken? So this table is something you need to master very well to assist you in your UTME exam. Okay, I believe that's right. Okay, so let's move on to the next thing. Is there any question on this? If you have no questions, so we can proceed. I believe we're on the same page, everyone. Okay, all right. So let's move on to the next. We want to consider density now. Density is also a subtopic under this when we talk about measurements. Measurements. We talk about measurement of volume. We talk about density. We are going to take measurements also as part of this class, but we want to consider a calculation under density, because we discovered that UTME always asks questions based on density. You can be asked to find the density of a particular question when you are given the volume and you are given the mass. You can be asked to find the density. So let's look at how we can solve those kind of questions. Okay, so I'll share with us a picture again to make it easier. All right, so we have all right, so density formula. We have density formula here given to us here. Okay, so we have density represented by this symbol. Take note, please, this is not P, this is not letter P. It's more just like someone writing something of this nature. All right, coming. Is not P, something of this nature, not really P. So take note in case you are solving and you see something of this nature, is not letter P, but it is the symbol that represents density. And we have density equals to mass over volume, mass over volume. So we have mass over volume as the formula for density. And also, most of the time you might be asked to find mass or find volume when you are given the density and mass. So I've already sent one of our picture here that give us the summary of the formula, okay? Yes. So with this, we already know the three formulas we are likely to have under the formula for density, okay? We have mass equals to density times volume. So if I'm asked to find the mass, I'm going to multiply density times volume, okay? If I'm asked to find density, it's going to be mass over volume. And if I'm asked to find the volume, it's going to be mass over density, mass over density. So these are the three formulas we have under the formula of what? Density, okay? So now, let's consider an application on that. Let's consider an application, okay? So if you are with me, please kindly signify you want to take an application on the formula of density. All right. So we are back to our board. We want to take an application on density. This should be app 3 for the day. Application. So I believe we can proceed. All right. So given the following information, given that M equals to 58 kilogram, then our V equals to 0.05 or 652 meter cube, and we are asked to find the density. We're asked to find the density. Okay, so we want to find the density of this question. Please take notes. I know we discussed about units in the previous class, and it is very important to always make use of the accurate units while solving. Mass was given in kilogram. In case mass was given in gram, we need to convert it to kilogram before we proceed to solve. Okay, and volume here was given in meter cube, not centimeter cube. So if you are given in centimeter cube, there will be a need for you to convert to meter cube before solving. Okay, so we have density equals to mass over volume. So our mass is 58 over the volume is 0.0562. Okay, sorry, 652. So by simple division, we are going to divide 58 by 0.05652. 58 divided by 0.05652, and that will give us the value of the density to be 1026.1854. So we can approximate this to be 1026.19. All right, 0.19. So that will be the formula to solve, and the final answer should not be like this. There should be a unit, of course. There should be a unit for this after solving this. If this is measured in kilogram and this is measured in meter cube, so I'll be having kilogram per meter cube. Kilogram per meter cube. So the density is 1026 kilogram per meter cube. 1026.19 kilogram per meter cube. I believe that's clear to everyone. So you can be asked to find mass instead of density. You can be asked to find volume instead of density or mass. So we've already given us a summary of the formula in our chat box. That's the image. So ensure you master this formula so that in case you're asked to find mass, you know the formula to use. In case you're asked to find the volume, you know the formula to use. All right. So if you are with me, please kindly signify. You want to take the next thing, almost rounding up. All right. Okay. Faith is with us. Thank you for your emoji. All right. So let's proceed. That means we can proceed. Oh, thank you. Awesome. I've received some feedback. Okay. So let's proceed to the next thing. We want to look at what measurement is. Measurement is, okay. So we'll clear our board. Measurements. All right. So measurements. Okay, trying to make it more for us to see. Okay. All right. Okay. So we have measurements here. We'll be talking about measurements now. A black ink. Okay. Measurements. So measurement is the process of determining a physical quantity. The process used to determine a physical quantity is said to be measurement. So the process at which we determine a physical quantity, that is, let's say I have a liquid substances and I want to know the volume of the liquid. So I'm going to take a measurement of it. I'm going to take a measurement of it. Okay. If I have, let me say, an object and I want to know the weight or the mass of the object, that means I need to measure the object to know the quantity of that object. So measurement is the process of taking measures of some physical quantity. Is that taken? So I want to quickly itemize some key things here. Take note that measurement is not perfect. Why? Because there are always errors of accuracy. I wrote here that measurement can never be perfectly precise due to measuring error. Due to what? Measuring error. Okay? And the limitations of accuracy of measuring instruments. Okay, so why is it that measurement cannot be precisely perfect? Is that there are some thing we call limitations of accuracy of each instrument, a meter rule, a screw gauge, a vernier caliper. All of them have some limitations of accuracy, and that is why the measurements we take most time are not accurately perfect. Are not accurately perfect. So take note of that. They are not accurately perfect. And also, it can be caused by human error. What I mean by human error is error due to parallax. Error due to parallax. You know, when you are doing physics practical, they will ask you to give some precautions you took while doing the practical. And most of us will write, I avoided error due to parallax. Error due to parallax is an error that is caused through the position of the eyes when you are viewing an object. Okay, when you are viewing an object. So when you have a measurement, let's say this is a cylinder, and we have the and there's a quantity of water in it that is slant like this. Okay, if you're asked to find the measurement of this, it will be very difficult for you to know what exactly the measurement is, because at this point now, you are likely to have what we call error due to parallax, because your eyes will be looking at the cylinder, but it will be your eyes will be viewing something slant. So you don't even really know what the exact measurement is. So that is also an error that brings about our measurement not to be precisely perfect or perfectly precise. Okay, an error called human error, and that is error due to parallax. Is that taken? So we are going to look at some instruments used for measuring some objects. Like we take the first one, instrument used for measuring the quantity length, instrument used for measuring volume, and so on and so forth. All right. So to make this more interactive, I've gotten us some image that will summarize those instruments used for measuring each of the quantities. Okay. So if you are with me, please check your chat box. I'll be sending those pictures right away. All right, so in your chat box, you see some pictures. So we want to look at some of the examples of the instruments used for measuring in physics, used for measuring quantities in physics. So if you look at the first picture, we have these instruments here are used to measure volume. They are used for measurement of volume. So we have the beaker, the conical flask, the measuring cylinder, the volumetric flask, the syringe, the pipette, and the burette. All these are used for measuring volume. They are used for measuring volume. So they are tools used for measuring volume. So you can be asked in UTME question, which of the following instruments is used for measuring volume? Okay, so the options can be mixed up. They will put some options that has to do with measuring length and some that has to do with measuring volume. So you have to be very conversant with the instruments used for measuring volume, that of length, and that of what? Mass. Is that taken? So these instruments are used for measuring volume. Let's check the next one. Okay, so this we have here, they are instruments used for measuring length. Okay, length. They are used for measuring length. We have this meter scale, also known as meter rule, measuring tape, the vernier caliper, and the screw gauge. The screw gauge. All these instruments are also used for measuring length. Okay, they are used for measuring length. And the next diagram here, we'll be having the instruments that are used for measuring mass. We have different type of them. We have the balance scale. Of course, some of us will be seeing this. Okay, sometimes when you go to buy meat in the markets, they use this to weigh the meat for you in kilogram. Okay, we have the platform balance, which is used mostly by stores that sells grains like rice, beans, and the likes. We have the analog weighing balance. If you are conversant of buying some grains also like rice, it is also used for measuring the weight or the mass of it. We have electronic balance. We have the spring balance. The spring balance. Okay. So we are going to quickly itemize the one that I use for measuring time. Yes, time. The one that I use for measuring time. And of course, um, we have for time, we have our stopwatch. It is used for measuring time. We also have our digital watch. Okay. We have the pendulum bulb, also used for measuring time. So all these are instruments used for measuring quantities in physics. All right. So a quick recap. Today we'll be able to touch dimension. Okay. We touch density, and also we consider some calculation on density, and also we touch measurements. We're able to see some example of instruments used for measuring length, used for measuring mass, and also used for measuring time. We talked about the one of time. We said the stopwatch, the digital watch, the pendulum bulb are all used to measure time. Is that taken? So please, I will want us all to visit the A1 Tutor app, practice 50 question on this topic. Go to the app, search for CBT question under UTME, and practice question that has to do with the topic fundamental quantity. Okay, so stay online. We are going to have the next class in few minutes time. You will not want to miss. We'll be having biology, and it will be great if you join the class to learn the more. Okay, stay online and see you later. Thank you for your time.